Today's video covers the so-called expected value. The expected value is the weighted average of random variables, considering the associated probabilities. With the expected value, we can determine which value or characteristic among various values is the most likely, meaning the one to be expected. It's important to understand that the expected value indicates the characteristic that has the highest probability after an infinite number of repetitions, not the characteristic that results from just one trial. The formula for calculating the expected value is EX, or the expected value equals 1 times P, the underlying probability, times, in parentheses, X equals 1 for the first value, plus 2 times PX equals sine 2 for the second value, plus 3 times PX equals sine 3 for the third value, and so on, depending on how many values are included in the calculation of the expected value. The expected value is often represented by the Greek letter mu. So much for the theory. Let's move on to a practical example. We have a task from a freelance chef who specializes in offering cooking lessons. To optimize his service offering, the chef wants to figure out which number of cooking lessons is most likely to be purchased as the first buy, that is, what to expect. For this, the chef has already obtained statistical data from a representative survey regarding the probabilities of the number of individual cooking lessons. According to the data, the probability that new customers will book only one cooking lesson as their first purchase is 0.5 or 50%. The probability of 2 cooking lessons is 23%. The probability of 3 cooking lessons is 13%. The probability of 4 cooking lessons is 10%. And 5 cooking lessons are chosen by new customers with a probability of 4%. Since we have the individual values and their underlying probabilities, we can now easily calculate the expected value. Plugging the values into the formula, we get expected value equals 1 for 1 cooking lesson times 0.5 for the underlying probability of 50%, plus 2 for the number of 2 cooking lessons times 0.23 for the probability of 23%, plus 3 for the number of 3 cooking lessons times 0.13 for the probability of 13%, plus 4 for 4 cooking lessons times 0.1 for the probability of 10%, and finally, plus 5 for 5 cooking lessons times 0.04 for the underlying probability of 4%. The expected value is therefore 1.95. In other words, the cooking lesson provider can expect that after an infinite number of repetitions, the value will approach 1.95 cooking lessons. So, the chef can assume that roughly 2 cooking lessons will be chosen by his new customers as their first purchase. Finally, the chef can optimize his offering accordingly and is pleased with the result of our calculation. We hope this video has helped you understand the topic of the expected value. See you next time and have a good one.